Hi everyone, greetings from Dr. Lord Francis Prabharan. Today we are going to see about a topic called direct memory access. It is a part of Unit 1 of Module 1 of Operating System course. Before going to see the technology and let us have some introduction about this direct memory access. Okay, let us consider I just want to transfer a data from a peripheral or a data to a peripheral. So what we follow? So we can follow two types that is mentioned here. One is moving data to a peripheral. So we'll be using some CPU instruction to write data from RAM to MIMO architecture. So we'll be following like this uh, data that will be moved to an array that is x of 1. Or another one type that is moving data from a peripheral. So that can be done with the help of some CPU instruction, that is some special instruction to data. So like this we will be performing. So here we can able to see the data move or data read, that is data write or data read, that can be performed with the help of microprocessor or microcontroller. So here, without any usage, our microprocessor is simply utilized. So the purpose of direct memory access is to transfer the data without the intervention of microprocessor or microcontroller. So why do we need DMA? So you can able to see one picture over here. So that is on x-axis we are having communication rate, on vertical we are having CPU usage. So here you can able to see the green line, that is without direct memory access, which is utilizing the CPU more. So that means for each and every data transfer we need a CPU. So the concept to implement this DMA is to implementing DMA by without using the CPU utilization. So with DMA we can able to see the CPU utilization is very less. What we need a DMA. So next we will consider the polling and interrupt driven input output concept based on data transfer between the processor and memory devices, and an instruction to transfer, that is move data to some register, only occurs after the processor determines that the IO device is ready. So either by pulling a status flag in the device interface or waits for the device to send an interrupt request. So considerable overhead is incurred. So because of several program instructions that must be executed for each data word transfer. And also the moving things is based on CPU instruction. So that is the reason we need a DMA. So with the help of DMA, that is direct memory access, we can able to transfer a large block of data at high speed. That is, this is an alternative approach for transferring a large block of data. So the block of data are transferred between external device and the main memory without continuous intervention by the processor. So just for initialization purpose only we will be using processor, and for another period we won't use this processor. So it is also another peripheral, but it is its only job is to move the data from peripheral or to peripheral. So for providing the connection we need a controller. So that controller is called as DMA controller, which is connected to the internal input output bus. So there will be some high speed bus architecture will be used for interfacing memory with the input output device through this DMA. So this DMA controller will perform the functions that would normally be carried out by the processor when access main memory. For each word transfer, it provides the memory address and also the bus signals that control the data transfer. So in DMA, the DMA transaction, so there will be some 6 stages are there. The initial stage, device wishing to perform DMA assets the processor bus request signal. In the second stage, processor completes the current bus cycle and assets the bus grant signal to the device. The device then assets the bus grant acknowledgement signal. The DMA device performs the data transfer from the source to destination address. And step number 5, once the DMA operations have been completed, the device releases the bus by asserting the bus release signal. And last step is processor acknowledges the bus release and resumes a bus cycle from the point it left off. So this is the overall flow diagram. So we can able to see in the step 1, that is processor which collects the data from the memory, and step 2, that is giving a DMA controller request the data transfer to a memory, and step 3, the data is transferred through the from the storage medium, and it is giving some acknowledgement, that is step number 4. And step number 5, when the interrupt will be generated once the signal got, then the data will be transferred between the GPU and the storage. So this is the flow diagram of DMA. So here the main important part that is used for DMA is buffer and arbitration. So most DMA have data storage buffer, and peripherals can send burst of data faster than main memory, so that will be handled. And bus arbitration is needed to resolve conflicts with more than one devices. That means we can either go with 2 DMAs or DMA and processor, etc. So try to use the bus to access the main memory. Bus, here in bus arbitration, we will be having some bus master. So the bus master is the device that is allowed to initiate bus transfers on the bus at any given time. When the current master relinquishes control, another device can acquire this status. And then the next one is bus arbitration. It is the next device to become bus master is selected, and bus master stick is transferred to it. So the arbitration approaches can be centralized or it can be a distributed one. So centralized means a single arbiter performs the arbitration. Distributed means all devices participated in the selection of the next bus master. So these are all the memory addressing space of bus DMA. So here in the right side we can able to see there is a high speed bus and low speed bus, that is AHB, that is advanced high speed bus, and APB, that is used for peripheral interfacing. So the corresponding addresses, everything it is given here for ADC, and then for timer counter, and then serial communication. Then we'll be having for, in the left side we can able to see for static RAM. Okay, in static RAM also we'll be having different bridges, that is AHP, APB bridge, AHP, APB, bridge B, bridge C, and then something that is used for flash memory. Then we'll be having, this is the global main memory that is given in the next part of this picture. And this is the memory architecture. So here we can able to see that there is a Cortex M0 processor with the maximum frequency of 48 MHz, and we'll be having some input-output peripherals, that is on the left side. So for that we'll be having input-output bus. Then we'll be having some on the bus architecture that is given as high-speed bus matrix. So that is connected to the DMA. So that is connected with your SRAM controller. Then we'll be having some bridges to interface between peripherals as well as high-speed bus matrix. So this is the memory architecture. So here one important problem in DMA, that is cache coherency problem. So imagine a CPU equipped with a cache and an external memory that can be accessed directly by devices using DMA. When the CPU accessed the location X in the memory, the current value will be stored in the cache. Subsequently, the operations on X will update the cache copy of X, but not the external memory version of X, assuming write-back cache. If the cache is not flushed to the memory before the next time a device tries to access X, the device will receive a state value of X. So everything it is given in the below figure, so you can able to check that one. So this problems is one of the major problem in the direct memory access. So this can be solved through some separate algorithms. Thank you all. In the next, we'll be providing with some quiz for evaluation purpose. Kindly attempt the quiz.